In this lesson, we will discuss the project background and provide a model tour of the windmill engine housing as part of a windmill water pump engine. The model that we will be designing is a vintage windmill engine housing that contained gears, bearings, rods, and other parts that were used to translate the rotational motion of the windmill wheel to the linear motion of a vertical water pump. The company that built this windmill, Flint and Walling of Kendallville, Indiana, claimed that their new design incorporating a new windmill wheel and blades and a gear pair using the new Timken roller bearings had a 30% increase in pumping capacity when compared to other similar-sized windmills available at the time. These windmills were once common all over the arid Midwest and West and reliably pumped groundwater into troughs for livestock, gardens, domestic, and other uses when electricity was either unavailable or expensive to route. In the West and the open plains, wind was frequent and reliable, and many companies were founded to manufacture and improve on the simple design of these windmill water pumps. There were dozens of manufacturers, with Flint and Walling being one of the larger ones, and innovations often sealed the deal. They patented this windmill that we will be designing in 1936 and 1937 and named their new model the Star Zephyr Model 37 Streamlined Galvanized Windmill. This was their last windmill model. Now that electric motors are becoming more available and reliable, it was apparently a big improvement on their previous year's models. The marketing brochure for that year states, Model 37 running an oil on Timken roller bearings with a double gear which are mounted on either side of the pumping rod balancing the load. Now, a neighbor of mine has recently acquired a vintage Star Zephyr Model 37 windmill that is now partially disassembled and stored on her ranch. This has given me a unique opportunity to examine and measure all the components of the windmill, then reconstruct it in SolidWorks before they install it and put it back into use. Beyond a typical model, this engine housing will be designed from the inside out and will initially use surfacing tools to get the shape just right. Ultimately, you will be leaving this tutorial with a pretty good understanding on when it's advantageous to use surface modeling techniques, as opposed to the more common solid modeling techniques on your own designs. So this is the portion of the lesson where we're going to be going through a model tour. This is going to be consistent for every lesson from this point on. So we're going to be having two models open. We're going to have a model called the windmill engine housing, which is going to be our reference model. So it's a complete model. It's got all the features in here that we want in this thing, as well as the surface features and a lot of the solid modeling features which help finish this. And then we're going to have our lesson model, which is going to be called the windmill engine housing lesson. And the lesson model is going to have our basic design sketches in here and our plans, our reference plans. Those things are going to be embedded into that. Now we're going to be using the geometry from both of those in order to build our model up. So to talk a little bit about our design sketches, this might be new to you, but what I have in here is sketches that are going to be primarily like on the front sketch or the top sketch or the right sketch. These are going to be elements going to be associated with all the items are going to be referring like perhaps with the front plane or parallel planes with the front plane, top plane, and the right plane. But essentially they contain elements in here that are going to be referenced for our model, from our model. Our model, all the features in our model are going to be referencing a lot of these elements in here. So a lot of the generalized modeling parameters are going to be inside of each one of these design sketches. For instance, if we want to change the pitch diameter of our wheel from like maybe 11 3/4 to 11, which we'll do later, we could do that and have the whole model change and update so we don't have to go through the 100 features that we have, 100 features or more in our model in order to make those changes and try to find those. And what it does is it takes all the references and puts them all the way at the top of the design tree. So if this is going to fail up here, we're going to see it up here. We should be able to fix it up here in our sketch before we have to try to hunt and peck down here in a lot of these folders where all of our features exist. So that's what a design sketch does. For those design sketches, we have a lot of reference planes. And in your lesson model, you're going to be starting with these design sketches and these reference planes in here. And then we're going to jump right into our surface modeling techniques. We're going to start with our extruded surface, our planar surface, our revolved surface, and so on and so forth as we move down our feature manager tree. So to finish this tour, let's go ahead and open up our this folder for interior wheel axle guide features. Let's take our rollback bar and let's roll that back down all the way to the bottom. This might take a few minutes for it to load. And what I've tried to do here with the rest of these features and these are all going to be solid modeling features from this forward on down, is with these features I try to label these. So as you go through your model, if you want to see how this model was put together, and there are a lot of fun things in here, including boss text, and some other elements in here that might be kind of fun to incorporate into your own design. You're welcome to pick through this and see how these things are done. So what I've done is I've labeled my folders and I labeled every feature in here so you know exactly what you're looking for when you're trying to find that particular feature. So with that said, let me show you some of the advantages of a design sketch. Let's say we want to go up here to our front sketch and we want to make some changes up here. You'll notice if you went through the previous tutorial talking about Spurrier design, that these numbers are based on that. And if you think about our model here, what we're doing is we're designing the inside of our enclosure first, which is really good. It's a good way to use those surfacing tools. It's a very good application for this, because then we can just use surfaces to make sure everything on the inside fits, including our gear wheel and our pinion gear and all the rods and hardware that go with that. And then we thicken it to the outside. So if we want to change things, like in our design sketch here, we can change maybe our pitch diameter to be maybe 11 inches from 11 and from 11 3/4, and maybe our outside diameter to be 12. We can do that and have the whole model change. So if we go ahead and rebuild this, this might take a little bit of time. It probably took a little bit of time too for it to rebuild the model after you pull your rollback bar down to the bottom. But there are 100 features in here, so it might take a little bit of time for it to do that. But it is updating everything, and what we're going to see is changing the model. Now, the intent of the design sketch is to have a one-stop shopping experience here, but sometimes it isn't perfect. And if you do have an error when you make some changes in there, you might probably want to go down here and try to find them. I think what happens, or what happened with this one, is that our hole actually is going off in a different direction. So it actually flipped the sides. Because what we want to do with that hole in that folder is go ahead and change the direction on that. So it's going to be blind. Let's go in here and change the direction to make sure that yellow preview is actually going through the model. Now this happened before too, and this is going to be one of the things we're going to try to correct when we go through our surfacing tools in our lesson model, probably around lesson 11 and 12, is that we're going to have another feature, and here's a solid feature that gets flipped and put on the outside of the model, and some of the things that might happen with that. So we're going to go ahead and take a look at that a little bit later, and you'll see what I'm talking about. So some things can flip in here, and if you make changes to one of your design sketches, you get an error. Hopefully it's just one error. You can go in there and actually fairly quickly be able to change things and make those corrections. So let's go to our lesson model and take a look at what we're doing here. Again, we're going to be starting with our design sketches, and we're going to be working down to our features, our surface features. So let's take our rollback bar and roll it to just underneath gear housing outer and take a look at how this model comes together. Let's go and right click on our design sketch and tell it to hide. And let's go ahead and build this. So let's take a rollback bar one at a time. What we're going to be doing is we're going to be doing two different extruded surfaces, and then we're going to add some caps to the end of this. So we have our housing outer cap, housing inner cap. So the inner cap is over here, and then outer cap's over here. And then we're going to be adding our vertical shaft. Now we hit our vertical shaft because we made a correction to this in lesson number 12. But you can see with the vertical shaft is we can take these two surfaces and actually have them intersect, and then we can do a trim where we can take this surface body here and actually trim the top part of that shaft. Pretty cool. It's very fast. It comes together really quick. It's a couple of mouse clicks and then you have that done. Solid modeling, it's a little bit harder. These oil pan items do the same thing. It actually, there's some surface bodies up here that we trimmed out, and we use both the surface bodies as a way to trim out each other, surfaces that were kind of interfering with each other. So we're going to go ahead and knit it. We're going to mirror it from one side. So now that we have that symmetry, we're going to mirror from one side to the other. We're going to put in our fillets, and eventually we're going to thicken it. So once we thicken it, now we have a solid model, and we're done with surface modeling. But the surface modeling got us to that point. Then we have some other elements in here too. We have a revolve feature and some other things which help correct the problems we might be having a little bit later with our surface revolve. So that's our tour of our models. Remember, we're going to be using surface bodies in order to create a solid model after that. So we're going to be using a lot of the surface tools and a lot of the surface features in order to ultimately get to our goal, which is a solid model. Now, these lessons may proceed rather quickly, but unlike what you might expect to find in a classroom environment, if you miss something here or just need to see it again, you could always interrupt the lecturer, press the rewind button, and see the previous steps over and over again and as many times as you like until you thoroughly understand the lesson at hand. However, if you still don't understand something that you see on the screen, feel free to contact me at design@edi3di.com, and I will try and provide a quick solution, usually with a video response by way of YouTube. So join me in the next lesson where we will borrow the geometry from our design sketches and begin to build our surface model.